1 minute ago, a towering column of volcanic ash punched through the afternoon sky above Java's tallest mountain. Within seconds, superheated avalanches of rock and gas began racing down slopes at speeds no human could outrun. On November 19, 2025, Mount Semeru unleashed forces that turned day into darkness and sent nearly 200 climbers scrambling for survival. What triggered this sudden fury? Why did alerts escalate twice in a single hour? And what does the footage reveal about a threat still unfolding at this very moment? The image spreading across social media shows brilliant forks of lightning tearing through a dense column of ash. It looks impossible, otherworldly, like something conjured by digital effects. But volcanic lightning is entirely real. When ash particles collide violently inside an eruption plume, they generate static electricity powerful enough to create lightning bolts. These electrical discharges illuminate the interior of the ash cloud, revealing the raw chaos within. Scientists call this phenomenon dirty thunderstorms. At Mount Semeru, cameras captured these lightning strikes carving through the pyroclastic surge as it descended the southern flank. The footage is not manipulated. It is evidence of the immense energy released when volcanic material fragments and collides at extreme velocity. Every flash marks a moment where physics transforms violence into visible light. But the real danger lies not in the spectacle. At exactly 2:13 p.m. local time on Wednesday, November 19, seismic instruments at Mount Semeru's observation post began registering unusual tremors. By 4 p.m., the volcano had erupted with a force that sent ash soaring nearly 2 kilometers above the summit. The eruption continued without pause. 10 separate pyroclastic events were recorded within 6 hours. Each one pushed superheated clouds of ash, rock, and gas further down the mountain's southeastern drainage channels. Indonesia's Center for Volcanology and Geological Disaster Mitigation raised the alert level to 3 at 4 p.m. 1 hour later, as pyroclastic flows reached 7 kilometers from the crater, authorities escalated to level 4, the highest possible warning. More than 900 residents were ordered to evacuate immediately. The exclusion zone expanded from 5 kilometers to 8 kilometers in all directions, with a 20-kilometer danger corridor extending southeast along the Besek-Kebokan River Valley. Ash plumes reached altitudes of 17.9 kilometers, high enough to disrupt aviation routes and blanket entire districts in choking gray powder. What began as routine monitoring had become a race against time. When volcanic ash meets human infrastructure, the encounter is never benign. Ash is not smoke. It is pulverized rock, sharp as broken glass, heavy as wet concrete. When it falls, it coats everything with a dense, abrasive layer that clogs air filters, shorts electrical systems, and collapses roofs under its weight. Vehicle engines seize when ash enters combustion chambers. Water supplies become contaminated. Crops wither beneath the suffocating blanket. Footage from the eruption shows ash clouds rolling over ridgelines and pouring into valleys like fluid. The speed is deceptive. What appears slow on camera moves with terrifying momentum on the ground. Residents describe the sky turning black in seconds, followed by a rain of hot debris that burned through fabric and skin. The pyroclastic flows themselves are far worse. These are not lava streams, but avalanches of superheated gas and volcanic fragments traveling faster than hurricanes. Temperatures inside these flows can exceed 700 degrees Celsius. Anything organic in their path is incinerated. Buildings collapse under the impact. The flows follow terrain, funneling through valleys and river channels, gaining speed as they descend. At Mount Semeru, the Besek-Kebokan Valley became a corridor of destruction. On the northern slope, 178 climbers, guides, porters, and tourism officials had set out Wednesday morning for the summit of Java's highest peak. By afternoon, they were stranded at Ranu Kumbolo, a lakeside camping area at 2,400 meters elevation. The eruption had begun without warning. Ash began falling around them. The trails back down were blocked by debris, and visibility had collapsed to near zero. Ranu Kumbolo sits outside the main danger zone, but the climbers were trapped. Overnight temperatures at that altitude dropped sharply. Many had minimal gear, some carried children. Radio contact with the base was intermittent. Rescue teams mobilized immediately but faced treacherous conditions. Ash-covered trails became slippery and unstable. Falling rocks and continued tremors threatened anyone attempting the climb. Search and rescue operations continued through the night. Helicopters could not fly in the ash-laden air. Ground teams used handheld radios and GPS to locate the stranded groups. By Thursday morning, all 178 individuals had been located and were being escorted down the mountain in stages. Hedi Triastiti, an official at the Center for Volcanology, confirmed that the camping area was safe from pyroclastic flows, but warned that ash exposure remained a concern. "They are safe and now being helped to return," said Priyateen Hadi Wijaya, head of the Disaster Mitigation Center. Relief mixed with exhaustion as families reunited at the base. Some climbers described watching the eruption column rise in the distance, not realizing until hours later that they were cut off from escape routes. Others spoke of fear giving way to cold, then to the grinding wait for rescue. For many, the memory of darkness descending at midday will not fade. But the mountain was not finished. When pyroclastic flows mix with water, they transform into lahars, volcanic mudflows that behave like rivers of liquid concrete. These lahars gather momentum as they sweep down valleys, collecting soil, boulders, and vegetation. They can travel more than 50 kilometers per hour and continue flowing for hours after the initial eruption stops. At Mount Semeru, heavy rainfall in the days before the eruption had saturated the ground, priming conditions for devastating lahars. Villages in the Besuk Kobakan drainage reported walls of mud and debris crashing through homes. Boulders the size of cars tumbled through streets. Some structures were buried under 4 meters of volcanic material. The Gladok-Perak Bridge, a critical link between communities, was threatened by the same forces that destroyed it during the 2021 eruption. Residents fled with whatever they could carry, leaving behind homes, livestock, and livelihoods. Photographs from Supi Turong village show rooftops barely visible above gray ash dunes. Fields that once grew rice and vegetables are now barren expanses of volcanic sand. Trees stand leafless, stripped by the abrasive force of the flows. Power lines dangle uselessly. Roads have vanished under meters of debris. The scale of destruction is measured not in buildings alone, but in the erasure of familiar landscapes. Entire neighborhoods have been reshaped by forces indifferent to human presence. Mount Semeru's eruption was dangerous not just because of its intensity, but because of the distance its materials traveled. Pyroclastic flows reached 13 kilometers from the summit, far beyond typical exclusion zones. The volcano stands 3,676 meters high, giving gravity immense power to accelerate descending debris. When lava domes collapse at the summit, as appears to have happened here, the resulting flows can funnel through valleys with little warning. The Besuk Kublakan channel acts as a natural conduit, directing pyroclastic material straight toward populated areas. In previous eruptions, the same drainage has delivered destruction repeatedly. Engineers have attempted to build diversion barriers, but the sheer volume of material during major eruptions overwhelms any defense. The speed of these flows leaves no time for evacuation once they begin. Seismic data shows that the eruption intensified rapidly. The first pyroclastic density current was detected at 2:12 p.m. Within 30 minutes, flows had reached 5 kilometers from the crater. By 4 p.m., the distance had doubled. Authorities describe the progression as relentless, with each successive flow traveling further and faster than the one before. Height, velocity, and volume combine to create conditions where entire villages could be buried in minutes. The ghosts of 2021 haunt every conversation about Semeru. On December 4 of that year, the volcano erupted after days of heavy rain caused the summit lava dome to collapse.
Pyroclastic flows and lahars killed at least 51 people, though some sources report as many as 69 fatalities. More than 10,000 residents were evacuated. Thousands of homes were damaged or destroyed. The village of Kira was buried under layers of mud and ash so thick that recovery efforts took months. Survivors from that eruption described sudden darkness at midday, the roar of approaching flows, and heat so intense it burned exposed skin from meters away. Many lost family members, homes, and the rhythms of life they had known for generations. The Indonesian government eventually relocated nearly 3,000 houses out of the danger zone, but relocation does not erase memory or loss. The 2021 disaster also exposed gaps in prediction. The eruption was triggered not by rising magma, but by external weather conditions. Traditional monitoring systems focus on internal volcanic unrest, increased seismicity, gas emissions, ground deformation. When an eruption is caused by rain destabilizing a lava dome, those signals may be absent or ambiguous. The result is an eruption that appears to come from nowhere. Semeru's eruptive history stretches back centuries. The deadliest eruption on record occurred in 1909, when pyroclastic flows killed 208 people and destroyed 38 settlements. Since then, the volcano has remained one of the most active in Indonesia, with frequent small eruptions interspersed with catastrophic events. Every eruption adds layers to the landscape and to collective trauma. Indonesia is a nation defined by fire and instability. The archipelago sits astride the Pacific Ring of Fire, a 40,000-kilometer arc of tectonic boundaries where the Pacific Plate collides with multiple continental plates. This collision drives the Australian Plate beneath the Sunda Plate in a process called subduction. As the oceanic plate descends into the mantle, it melts, generating magma that rises through the crust and erupts at the surface. The result is more than 130 active volcanoes scattered across the Indonesian islands. Some erupt continuously at low levels. Others remain dormant for decades before exploding with catastrophic force. The same tectonic forces that create volcanoes also trigger earthquakes, tsunamis, and ground deformation. Indonesia experiences thousands of seismic events every year. For the people living here, volcanic risk is not abstract. It is a daily reality woven into geography, agriculture, and survival. The fertile volcanic soils support dense populations. The same mountains that threaten with ash and fire also provide water, minerals, and land for farming. This paradox defines life in the shadow of active volcanoes. Semeru's position on Java places it among the most monitored volcanoes in the world, yet monitoring cannot prevent eruptions, only provide warning when conditions allow. Within hours of the eruption, disaster response teams mobilized across East Java. The National Disaster Mitigation Agency coordinated evacuations, shelter operations, and rescue efforts. More than 900 residents from villages in the Lumajang district were moved to temporary shelters in schools, mosques, and government buildings. Some shelters quickly filled beyond capacity. Others struggled with shortages of food, water, and medical supplies. Local officials described the evacuations as orderly but urgent. Sirens sounded across at-risk communities. Loudspeakers broadcast instructions in Javanese and Indonesian. Families loaded motorcycles and trucks with belongings, children, and elderly relatives. Many left pets and livestock behind, uncertain if they would find anything standing when they returned. Search and rescue teams patrolled the danger zones, looking for anyone who had not evacuated. Heavy equipment was staged near affected areas, ready to clear roads and access routes once the eruption subsided. Medical teams treated burns, respiratory issues, and trauma among evacuees. Authorities warned that the eruption could continue for days or weeks, meaning shelters might become long-term homes. The logistics of evacuating nearly 1,000 people in the shadow of an active eruption tested every system in place. Communication networks were strained, roads were blocked, ash continued to fall. Yet the coordination held, and no additional fatalities were reported in the immediate aftermath. But many remain missing, and the search continues.
Satellite imagery from the Volcanic Ash Advisory Center in Darwin detected ash plumes drifting north and northwest from the summit. The ash reached altitudes high enough to pose a direct threat to aircraft. Volcanic ash can destroy jet engines by melting inside combustion chambers and then solidifying, causing total engine failure. Airlines avoid ash clouds at all costs. As of Thursday, no airports had been closed, but flight routes were being monitored continuously. Aviation authorities issued advisories warning pilots to avoid airspace near Semeru. The ash clouds movement depended on prevailing winds, which could shift rapidly and spread the hazard across wider areas. Delays and cancellations remained possible if ash concentrations increased or if wind patterns changed. For travelers in Indonesia and neighboring regions, the eruptions served as a reminder of how quickly volcanic activity can disrupt air travel. The 2010 eruption of Iceland's Eyjafjallajökull volcano grounded flights across Europe for weeks. While Semeru's eruption is smaller, its location in one of the world's busiest air traffic corridors means even minor ash dispersal can have significant consequences. Monitoring continues around the clock. Despite the danger, millions of Indonesians live on or near active volcanoes. The question is not why they stay, but why the land continues to support life despite the risk. Volcanic soils are among the most fertile on Earth. The ash and lava deposited by eruptions break down over time into minerals that enrich the soil, making it ideal for agriculture. Rice, coffee, vegetables, and tropical fruits thrive in volcanic regions. For generations, communities have balanced risk with reward. Families farm the same slopes their ancestors cultivated. Markets sell produce grown in ash-enriched fields. The rhythm of planting and harvest continues even when tremors shake the ground. To leave would mean abandoning livelihoods, ancestral lands, and the only home many have known. History offers parallels. Pompeii and Herculaneum flourished at the base of Mount Vesuvius, drawn by fertile land and trade routes, until the eruption of 79 AD buried them. Yet even today, millions live in the shadow of Vesuvius, gambling that the next eruption will not come in their lifetime. At Mount Semeru, the calculation is similar. The volcano provides as much as it takes. The challenge lies in knowing when the balance will tip. On November 19, 2025, Mount Semeru demonstrated once again that it remains one of Indonesia's most active and unpredictable volcanoes. The eruption that began in the early afternoon sent pyroclastic flows racing up to 13 kilometers from the summit and generated ash plumes that reached nearly 18 kilometers into the atmosphere. Nearly 200 climbers were trapped overnight and later rescued. More than 900 residents were evacuated from villages in the danger zone. Infrastructure was damaged, homes were buried, and the landscape was reshaped by forces moving faster than any evacuation order. Authorities have maintained the alert at level 4, the highest warning. Exclusion zones remain in effect. Seismic activity indicates the eruption may continue for days or weeks. Lahars triggered by rainfall remain a persistent threat. The Besek-Kokopan Valley, already scarred by repeated flows, faces further devastation if the eruption intensifies or if heavy rains return. Scientists cannot predict when the volcano will calm. Monitoring stations track tremors, gas emissions, and ground deformation, but the triggers for eruptions at Semeru often lie beyond the reach of sensors. Rain, dome collapse, or shifts in magma pressure can all spark sudden violence. The mountain holds its own timeline. For the families sheltering in schools and mosques, for the climbers who survived the night on the slopes, for the villages buried under ash, the question is not if Semeru will erupt again, it is when and whether the next eruption will be worse. What secrets does the mountain still hold?